very important. So one thing with a circle, what defines a circle? Its center and the length of its radius. So if we can use this radius to help us out, that would be most useful, wouldn't it? I'm going to say that we're going to start out figuring out how to measure, what would we call the half revolution of a circle? Call it a semicircle, and how many degrees does it have? 180 degrees. But now I want to measure it in terms of a length, and I'm going to use the radius, the length of the radius, as my way of measuring my angle. Now it's going to change. It's not going to be called a radius anymore. I'm going to call it a radian. So radian. This length is going to be then curved. We see it here. There's one. If I took this radius and curved it, this is exactly one radius in length once I've curved it, and I'm going to call it 1 radian. My second radius, I haven't quite got to a half a circle or a semicircle yet. I'm looking to get to 180 degrees. I've got 2 radians. So let's put another one on here. Here's my third radian, and now I'm almost there. So just a little bit more than 3 radians will define 180 degrees, or a half a circle. How much more do I put on here? This little piece here is less than 1. So halfway around a circle is 3.1416, going on and on and on. Thank you. There's a few of you thinking or talking about this. Yes, but that is pi. So how many radii does it take for me to get halfway around a circle? Pi radian. Okay. How many radians are in 90 degrees then? If it's pi radians to do 180, and I'm talking about 90, what's this angle measure in radians? It's not pi, it's half of pi. How many degrees are in a third of pi? A third of pi radians. 1/3 pi radians. So that looks something like this. Pi over 3. Yeah? What is it? It's 1/3 of 180, isn't it? Pi radians is 180 degrees, so 1/3 of pi radians will be 1/3 of 180. Okay, so let's use this now. We're going to find the length of an arc intercepted by a central angle. So we're talking about a circle with a radius of 5 inches, and the central angle is half a radian. Well, we know 1 radian would be right here, wouldn't it? And what would the arc length of 1 radian be? Exactly equal to the length of the radius. So 1 radian, if I went around, 1 radian would be 5 inches. So if I go a half a radian, it's going to be 2.5 inches. Find the radian measure of a central angle that intercepts an arc of length S in a circle of radius R. Oh, no numbers? Okay, let's see if we can use the same thinking and figure this one out. I'm going to draw my circle up here. Okay, we have radius R, and we have an arc length of S. It's a weird looking S, but we know what it is. And I want to find this measure. Notice when we're dealing with arc length, we're always talking about radian measure. Degrees will not work. So I know my answer is not going to have number, well, it may have a number, but it's not going to have a number value for me. How did I find it over here? The arc length was 2.5, and I found that because, let me see, my radian measure on this one, I should change colors. Whoops, that's fancy pen. Let's go to blue. Okay, my radian measure on this one was 0.1, right? Half a radian. So, I mean 0.5. 0.5 radians. My radius was 5. And how did I find my arc length? As long as I had this in radians, I could find my arc length this way. It's quite simple. The radius times the radian measure of the central angle. So why wouldn't this formula still work for me here? Find the radian measure of a central angle. So it's going to be radian measure equals arc length divided by radius. That's supposed to be an R. This could be a very handy formula. Okay, let me take a look at the answer I figured out last summer. That's right. This is a very handy formula. I'm going to use this. In almost every lesson, we're going to have an example that we work through. This is work that you should have completed in your notebook. You don't have to do it along with me. You can shut me down right now and then go ahead and do it and then come back and check your answers. 180 degrees. Well, let's move backwards for a moment. Might be useful for us to grab this. Copy. You've got it in your notes probably. But, oops, I see even a better one right here. I'll copy this one. Copy.